Welcome to Advanced Guide to HTML5 in Drupal. Skip through this. This is basically thank you for coming out. Got to pay the bills. But this presentation is brought to you by Media Current. If you're going to do Drupal right. A little bit about me: bachelor's in fine arts. I've been working with Drupal since 4.7, and my favorite build is watchgmc.com. Favorite Drupal install, and I do UX design and theming with Media Current.
Got a bachelor's in computer science from Furman University. Been doing web space work for about 7 years. Started working with Drupal at 4.7. I'm a developer at Media Current.
And that's Josh Estep. So a little bit about Canvas. Basically, we're here to say what is art, right? We're not going to explain get into debate of what art is, but you can curate some beautiful things in Canvas. So to explain that a little bit better, Josh is going to walk you through exactly what Canvas is.
Yeah. So Canvas is an HTML element containing a bitmap image. So pixels are rendered and changed dynamically by JavaScript. Canvas is blank until JavaScript populates it. Canvas bitmap scales to fit the Canvas element. If you have a dynamically generated graph and need to resize it, it's a trivial process as long as the data is still readable. So the content on the canvas, for example, a rectangle, can't be manipulated directly. You can't target the rectangle and shift it up. What you do is redraw the rectangle in a different position. Alternatively, you can modify individual pixels for fine-grained control. And the Canvas bitmap image can be exported as an image. And if you export it as a JPEG, you can also specify the quality of the value quality. Okay, so here we've got some code that displays the canvas and adds some rectangles to it. There's a canvas element with the ID of foo. In the JavaScript, we use get context to gain access to the canvas. You'll notice the context we're using is 2D. It is possible to use other contexts, but the code we're focusing on today is specific to the 2D context. Next, some context attributes are set: shadow, blur, color, and the offset of the shadow. After that, we set the fill style to indicate color, in this case red. You can use hexadecimal or RGB. So finally, fill draws a rectangle with the top left corner of the specified coordinates, in this case 150 by 150, and with specified dimensions. And in this example, 2 additional rectangles are added, but it's not necessary to redefine shadow settings.
So granted, you see the interesting part about this is how you put the canvas on the page, with the 2 tags, and then the second part is how you apply, push data into that canvas.
Same slide. So it's go back up to 8. Okay, so you may notice that the canvas elements width and height attributes are 1,000 by 1,000, whether its CSS is set 200 by 200 pixels. So this isn't ideal. This is done to demonstrate canvas element scaling. So canvas elements width and height attributes set the size of its bitmap. In contrast, CSS sets the size of the canvas element itself. So if the canvas doesn't define dimensions, then the dimensions provided by the canvas element will use. So in this case, the canvas would span 1,000 by 1,000 pixels on the web page otherwise. By default, if nothing's specified, then both the canvas and its bitmap will be 300 by 150 pixels. And if the CSS dimensions are provided, but canvas width and height are not set, then the canvas bitmap dimensions will default to 300 by 150. But will scale to fit to fill the CSS-based dimensions of the canvas element. Ideally, you want it to be pixel per pixel, but this allows for scaling. So in this slide, the CSS dimensions remain 200 by 200, but the canvas element dimensions have been decreased to 500 by 500. Since the code draws outside the 500 by 500 in the bitmap, only some of the images displayed. Decreasing canvas element height. So finally, 500 by 500 remains, but we decrease the canvas element height, and then you see, the same content as the previous slide, but it's half as tall. So that's kind of what the canvas element looks like. Okay, so in this example, we have the first 2 rectangles but the save method has been called after each. Save stores the current state of the context attributes to a stack, and it can be called multiple times. Next slide. In this slide, after the second save, we call restore, which loads and saves state of the top of the slide and pops it off of the stack. So begin path identifies the start of the current item we're drawing. Arc indicates a curve. This one in particular draws a circle. A closed path makes the beginning of the path connect to the end. And fill populates the inner area of the shape with color. This is repeated with the circle with another restore call. And you'll notice the first circle is green, like the second rectangle, and the second circle is red, like the first rectangle. Okay. In this example, toDataURL is called to return the data URL representing this image, or the image that would be generated from this. This is used to display, this is using the data URL scheme, which allows me to be embedded in inline. Scroll down, or next one. Okay, what you see here is actually the data that's output. So here's a subset of the characters returned. The file size for the full set of characters is around 70 kilobytes. And if you copy the whole data URL into the source attribute of an image tag, the image will be displayed. Okay, next we'll review some drawing methods that can be called via the context object. Okay, so drawing text is similar to drawing shapes or paths. You define some attributes and then draw the text. A CSS style font definition can be used. There are two ways to draw text. Fill text, which draws the text the standard way, and stroke text, which draws an outline of the text. Beyond this, the measure text method can be called to determine the width of the text to be displayed based on the previously set attributes. So you can use this to help determine whether text will fill before it's rendered. It is also possible to add images to the canvas via the draw image context method. This method has three forms. Here we see the simplest, which displays the image in question 100% at the specified coordinates. Next. In this form, we also set the image's location and scale the image itself. Finally, in this example, we only select a subset of the source image, then display it at the location with the scaling. Next. Okay. Here we provide, we previously touched on begin path with drawing an arc. This example introduces the move to method which sets the starting point of the path. So line 2 defines the line from that starting point to a given location. Finally, the stroke command renders the line on the canvas.
So this is kind of like where you can use it to animate, create dynamic drawings on the screen.
Okay, so here's line 2 repeated. Here's an additional call to line 2 starting from the end point of the previous line segment and draws to the coordinates indicated. Nice. Here's another one. Next.
So you just stack
And another, and again, and again. Okay. Okay, so here we see the fill command, and then one more. Okay, in addition to the arc method, with create a linear gradient, you see, you instantiate a gradient object and pass that to the fill style to do gradient fill. A radial fill is also possible, and you can have, any number of gradients. It doesn't just have to be between two colors. Okay, next. In addition to the arc method, there are other kinds of curves that can be drawn. This example, a quadratic curve 2 replaces the line 2 call, and the first two values indicate a control point which kind of pulls out the curve. Okay, pixel manipulation. So it's possible to set a single pixel, but this is kind of tricky because pixels are stored as an array that fills the image left to right, row by row, where every 4 elements in the array define red, blue, green, and alpha, or opacity. So to do this, you can call get image data, return the current image, or you can do create image data if it's new image. So this gives you an array. So to set a pixel, you first determine the starting index of that pixel by multiplying the desired y value, that coordinate, by the image width to get the row, and then adding the desired x coordinate to that column. Finally, you multiply that value by 4, which accounts for the 4 indices for each pixel. So once you have the starting index, you can set the RGBA values for where the index itself is red, +1 is blue, +2 is green, +3 is alpha. Finally, put image data inserts the grid pixels into the bitmap at the specified location. Next. Okay, so browser support. Canvas is supported by modern browsers. Maybe some workarounds needed for Internet Explorer.
And you can use, I don't know if you was in the last session, but you can use Google Frame to implement this as well. And I think past 9 or so, you have to probably use a Shiv or some type of JavaScript library to create the Canvas feature.
Yeah, so and some different things you can do with the canvas. You can, for example, render charts and graphs. So that could be done with Drupal View potentially.
I think Google also has something very similar that they use the canvas produced there.
Another application is image editing. So this is an interesting demo. There's all kinds of things you can do, and it's possible because you have the granularity of pixels. Okay, and you can also implement games. A while back I saw a port of Doom, a classic 3D first-person shooter, to the canvas, so I thought that was pretty impressive.
Yeah.
Okay, next we'll talk about SVG, which was touched on a bit in the previous session. So SVG stands for Scalable Vector Graphics, means you can resize as much as possible without any pixelation. SVG defines graphical elements via XML, so you can drop SVG code directly into a HTML document and it will show a static set of graphics without any JavaScript rendering needed. Excuse me. However, elements can be added and manipulated via JavaScript. You can also do things like attaching events, like a mouse click, so it can be interactive. Next. Okay, so here we define CSS styles for the SVG elements where each item has a 5-pixel red border, is filled with color green, and has 70% opacity. The SVG element defines where content is rendered, and each item defines its location and size with attributes, but the red-green class attribute is used for styling. So this is stylable, which I don't believe is possible with Canvas.
Yeah, so basically SVG is more preferred. Depending on what you need it for, I would go SVG route over Canvas, but it's all based on what your needs are.
Yeah, Canvas gives more fine-grained control. So yeah, comparison. So SVG again is vector-based, whereas Canvas is a bitmap. And although it can be scaled, it'll be pixelated. Okay, so SVG content can be accessed and modified directly via XML definition, CSS, and JavaScript, whereas Canvas, you're kind of limited. You can, it has to be rendered on load, and access to its content is limited. Next. Okay, so I think that's cool. Well, next we're going to talk about web workers. So
they're kind of like Smurfs.
Yeah.
It's like, they kind of do these things in the background and they bring up their goodies.
Yeah, think of web workers as Smurfs running around the village of your website, or maybe not. But because JavaScript is a single thread system, it's difficult to orchestrate multiple actions at the same time, and this can bog down the browser. So that's the problem web workers are attempting to solve. Actually, go back one. Right, so web workers can execute in parallel and actually run asynchronously in OS level threads. They can work across multiple tabs or windows for a given site due to the separation from browser UI activity. They can handle CPU intensive tasks without freezing or slowing a web page. Workers can spawn child workers, which can be used for things like recursion. Each worker can make use of set timeout and set interval. So within that worker, you can limit how often it fires.
So say bye-bye to cookies. No cookies.
Okay, 39. So here's some example code. First, we instantiate a worker object. Then we use onMessage to define the action to call when the worker code sends data to its parent script. The post message method is used to both send data to the worker and receive data from the worker. And then finally terminate stops it. Next. Okay. Next we'll discuss drag and drop.
About drag.
Drag again.
It's just drag, but just imagine the drop in there. Yeah.
So here you see a screenshot of a file upload dialog box in Gmail. So on the left, you have the standard, upload dialog, but on the right, you have the drag and drop interface. So this can improve usability. So some benefits. It can make implementation more intuitive, more app-like. It can assist with activities like file management as well as photo management from both the desktop to the client and within the page. So it handles both. I think Chrome may do some transfers from the web client to the desktop, but I'm not sure that that's part of the standard. Number 3. Okay. Here are a list of drag and drop events which actions can be performed. So JavaScript can determine when the dragging is stopped, when the item is entered, left the draggable area, when the item has been dropped. So you can have a lot of control about how the dragging and drop process works. Okay, next we'll discuss offline browsing. So it's a frustrating page to see. However, HTML5 makes it possible for users to continue using a site without net access.
So basically, if you're on a mobile phone and you're riding through a tunnel for whatever reason, this feature will allow you to download a certain portion of the site and keep it operating until you get a new connectivity.
Okay. Go back up. Yeah, no, you're good actually. Okay. So now we'll talk about web storage. So web storage is a method for storing data offline. Set item and get item methods used to set and get key value pairs of data. Session storage and local storage both store data, and the difference is session storage only retains data for the duration of the user's browser session, whereas local storage will persist until JavaScript removes it or the browser cache is cleared. IndexedDB, I'm not sure I'm a fan of this, but another way to store client-side data. This is persistent data storage, which lasts beyond the session. It can be used both synchronously and asynchronously. So if you're performing a data search and you want to do it synchronously since the user's waiting a response, I would think. But something like preloading data could be done asynchronously to avoid slowing the web page while the user is doing other things. This is a non-relational database. So rather than storing data in a table like MySQL, you define a type of object store and then populate with objects which can be queried.
As a side note, Node.js is something you can check into here that may help with offline storage.
Okay, so this is some code related to this. So in this example, we define data to store at the top. Set version identifies the version of the data structure. So if you change your data structure, you would have a different version. Of course, on error handles errors. On success is where activity takes place. Create index creates an index to search for names and emails in this example. And finally, add method adds data to the database. Okay. So web storage versus IndexedDB. So web storage is a simple key value map that's easy to use. IndexedDB is much more complicated but can do more. Finally, IndexedDB is transactional where web storage is not. So if two processes submit data to web storage, it's possible the second one could overwrite the first one. So you know all that. Next, we'll discuss client-server communication as well as communication with users. So here we have a JavaScript alert. This blocks access to the page and only displays one at a time. Okay, so notifications is much more flexible. It's not limited to the current tab or window as it's displayed on the desktop. It can contain both plain text or HTML. It's asynchronous, so if a notification won't stop you, you can continue what you're doing. So this is a screenshot of what 3 look out of Chrome. In this example, there's first a check that notifications can be displayed, then it's displayed if possible. Otherwise, users prompted, which is typically a bar across the top.
So you can, it's kind of like Growl, anybody have that? Think of it like that. You can have real-time interactivity with your website. You can display messages well beyond the JavaScript alert box. You can do something a lot cooler.
Okay. So WebSocket. WebSocket allows communication between the browser and server. It's pretty straightforward within the browser. So where you first instantiate a WebSocket object, and then you provide the associated server URL. You define what happens when a WebSocket is open, define what happens when the server sends a message and finally send a message to the server. So WebSockets are bidirectional, use a persistent connection, and the tricky part is it requires a server-side process, which I'm not going to get into today. Finally, geolocation. Here we'll see a pop-up. Here we see a pop-up requesting permission to access user's location. Geolocation usability is limited by this, but it's necessary for security, and it persists beyond the current session. Okay, so the location data and its accuracy are limited by the device being used, but if available, you can get a lot. So you can get longitude, latitude, altitude, heading, speed, as well as measurements of accuracy. So, mobile devices, this is going to come up. So what does this have to do with Drupal?
So
these are, go ahead.
Well, basically, there are a few modules out there that interact with Canvas. I think there's one on there. Was more so like audio type of module I've seen. You can play audio, and it draws the audio timeline, things like that. Video, that type of thing. It uses certain aspects, but mainly, in Drupal, it's really more or less not a module per se that supports it, completely. It's just installing the HTML5 support script, JavaScript, things like that will help HTML5 recognize, IE recognize the latest, entities, things like that. That's really the main important task. And I would say use Google Frame. That's a good way to get it to work in browsers older than 9, things like that. But in the future,
I was just gonna go through.
Oh, you?
No, that's cool. That one. Yeah. So, what might the future hold for Drupal? So, here's some possibilities. So first is graphical view results. With the Canvas or SVG, it's possible to render graphics dynamically, so you could do that with view results. So you could possibly create a pie graph or a chart of data on the fly, maybe make it interactive. Preloading view search results. So with web workers, results could be potentially preloaded both for performance and for offline browsing. So you do a search query on your site, you lose your internet connection, but because of maybe some preloading in the background, you might have a couple more pages you could browse through. Updates could be provided when content has updated via notifications. This could benefit content managers, sites with frequent updates. Chat-based content discussion. So, WebSocket lends itself to inline chat. So, in addition to a comment section, users could access a chat section for a node to discuss it in real time, and then that could be logged and saved later for additional content.
And I know, side note, Node.js actually has a module. It's I think it's Project Node.js, or I think it's called Discussion or something like that. Boy, they actually implement a full, version. I don't know if it uses the web workers in the back end, but something to check out.
So drag drop administration. There's already a little bit of this in Drupal, but it could be expanded. So, uploading content or managing data could be more usable by dragging images or files from place to place rather than, uploading dialogues. And I'm sure there are many other, use cases. Collaborative node editing. Maybe there's a situation where it's beneficial to have two people, modify a node like in Google Docs. Users could collaborate, and the updates would appear in real time. Custom fields. So, custom fields can be tricky, can take a lot of time, difficult to support in multiple browsers. So rather than rendering a custom field with jQuery and CSS, SVG or could be make it easier. So you could have a clickable area, stylable graphics. So I think that would cut some time off.
In the last session, I don't know, you can create cool fonts, SVG. You can, do all types of animation effects, combining the two. So something that you will see more often, just on the web in general, in and out of Drupal.
And code-based art generation, or just like making your theme, kind of like what we were seeing in the last session, dynamically generate the style of the site with less custom work. Image generation can happen on the client side instead of via PHP libraries on the server.
Okay. Well, guys, thank you. That was our presentation. We appreciate you bearing with us at the start of it. But, any questions about HTML Canvas? Back.
Question on WebSockets. Are there the same sort of security restrictions imposed on those as there are on Ajax with cross-site scripting?
My understanding is it's limited to the current origin, so I think the answer is yes.
You
programs specifically for Canvas?
said drawing programs?
Code.
I just found one for Illustrator. Illustrator for Canvas, yeah, and I just tweeted about it.
Yes.
Drupal Canvas. And anybody didn't hear that, like I just found a link that will translate your drawings from Illustrator to Canvas, because that scared me, and it looks really awesome, but I'm like, I can't write that.
Yeah,
So I started looking for a tool, so
Yeah.
look at Twitter.
So there's another question.
When we were showing the Canvas drawing tool, is there a way to time the drawing, or is it's just rendered once, or?
What you would do there is, so it's, how would you do animation within the canvas? There's multiple ways. If you're doing it at the pixel level, then you would really just get all the pixels, make your changes, and update really quickly. You can also break off various elements in the canvas into their own objects, and then save and restore the state of those as needed. So it is possible.
Any other questions?
Would you paint those into a div and then animate the div or something?
So would you paint the canvas into a div and then animate the div?
Possibly, but if I was doing something on that level, I'd probably lean towards SVG. Canvas is more fine-grained. If I want to do something with a lot of tiny pixels, a lot of effects that can't really be done with SVG. So I would say a good rule of follow would be, if possible, use SVG. It's a little bit more straightforward, but it's more process intensive. Canvas is more efficient, but it's a little bit more complex to program. Setting a pixel is kind of complicated. I mean, I'd put all that in a function, but still. Any more questions?
No? Okay. Thank you, guys. Have a good
Thanks.
day.